Hey, it's me, Steve. It's November 24th, 2017. Time is 7:27 Central Standard Time, even though I'm in Eastern Time. It's about 33 degrees Fahrenheit out now, but it's supposed to be almost 50 today. And what I'm doing here is a quick intro because I'm going to cross the border into Canada, and I'm going to take you and show you some rock outcrops. I'm on my own today. So this is the only time you'll have to see my ugly mug. So anyway, that's it. Let's get started. This is the International Bridge between the UP and Ontario. This is our first outcrop. I'm facing south right now. I'm on Government Road, Trans-Canada 17. You can see cars moving on it right there. I'm going to do this one from the Jeep because there's some stuff I want to show you here, and it's better to do it from a distance. Okay, this is GPS 46.46188 minus 84.05813. It is 8:45 Central Standard Time out. And what you see here, this is interesting. I'm going to show you, this is a long outcrop. I studied this in detail. Right here, what you have is the Jacobsville group. This is the Orienta Formation, but here it's a little different. It's got something in it. You see these recessed parts right here, these deeper red. That's actually shale and shale class conglomerate. Here the Jacobsville is probably around 920 million years old. And if you notice the beds, they're kind of dipping this way, kind of to the north, which is to my left. And it's all sandstone, it's arcosic, it's not a quartz arenite. But you come up here, right here, this is a fault. This right here. You have Jacobsville on this side, you can see the beds dipping this way, and on this side you have the Lorraine Formation, which bedding is this way. The Lorraine is a lot older, about, off the top of my head, I want to say 2.3 billion years old, and it's a quartzite here. It's metamorphosed. Its parent rock is a quartz sandstone. Now you have the fault here. You see the difference in bedding. Now we're going to go through here a little further. This was quarried out at one point. Okay, so now we're totally right now looking at Lorraine. We're going to see this again on this trip. Here it weather's pinkish, but it's actually very white. You can see how it was quarried out here for stone at one point. Okay, we're still in the Lorraine. And then we get to right about here. There is another fault here. All right, we have Lorraine here, and we have Jacobsville on this side, and the Orienta here is dipping this way a little bit. It's nearly flat, but the fault is right here. And so what we have here is the Lorraine is a horsed structure. We have, it is basically up like this. You have Jacobsville on this side, Jacobsville on this side. The Lorraine, it's bounded by two faults, has been lifted up relative to the Jacobsville. So this is a fault. This is not a depositional contact. I originally thought it was, but it's not, because the Jacobsville is lacking clasts of the Lorraine. If this was a depositional contact, the Jacobsville would have clasts of Lorraine in it, since it's right here, and it doesn't. So this is definitely a fault contact. And now we're going to go a little further. Hopefully the sun won't get in the way. And you can see Jacobsville. Now we're back in the Jacobsville. It's over here. This is all Orienta sandstone of the Jacobsville group. You can still see some of the red shale. It's on this side as well. There's some right in there too. There's actually more on the bottom. I'm not going to get out and crawl up there because, like I said, it's better to see this from a distance than it is really close up. And we have all Jacobsville right here. There's a series of small, tiny, you can kind of see one right. Let me see if I can zoom in. This right here is a tiny fault. The offset's, it's less than maybe 2 feet, if I remember correctly off the top of my head. Might be less than that. It might only be a few inches. But that's the entire length of the outcrop here at this location. So just thought that I would share that real quick with you. I'm looking due east right now. And we'll just pan back down the road so you can get a good look at it. Now I'm just going from south to north. Show you the whole thing again. Orienta. Fault. The faulted up part of the Lorraine. Pronounced North Fault, Jacobsville, Orienta again. Okay, we are at 46.3782 north, minus 84.00680. That way is east. I'm on Trans-Canada 17. There's the sign from McKnight's Road, that green one here. But I'm just stopping here real quick because I want to show you something. This here, you get these very pink, now it's Truck Alley here. Okay. Alright, this rock here is the host rock. You see it's fine grained. This is, I believe, the Gauganda, which is, here you see some laminations. This is one of the oldest formations on the planet containing glacial deposits, although here I believe it's mostly marine or nearshore marine. You'll see calcite in it, and it dips. It's dipping this way, but here's a close-up look at it. You can see lithic clasts in it, but that's not mainly what I wanted to show you. You're going to see this again as well. I wanted to show you these red syenite dikes that trend almost due west to east here. You can see it up here too. And there's a bunch of them over here. You see it there. You can see them on the opposite side, that's south of the road as well. These syenite dikes, we're totally unsure of the age. No one's ever really studied them, I don't think. We know the Gauganda is about 2.4 billion years old, so these have to be younger. And like I said, not sure of the age. Could be related to the Nipissing intrusions, or could even be younger than that, and could be related to the Mid-Continental Rift. But you can definitely see some intrusional features right here. You can see baked zones, these black areas, as the syenite was intruded into the Gauganda. There it is with no baked contacts. No baked contacts, you get the red syenite, then you get clasts of baked and altered Gauganda in it. And I think that's good enough for this outcrop. I'll show you this real quick. This is facing east. Cool sedimentary feature here. We're still in Trans-Canada 17. I believe that's due east, I think it is. We are GPS 46.33746 minus 83.95405. It's about 9:15 in the morning, Central Standard Time. But what I want to show you here, this is also got, no, this is basal Lorraine. The basal Lorraine you saw at the first stop, this is stop 3, was mostly a quartzite. Here, it's mostly a slate. And what you see here are ripple marks. All up and down this outcrop. Right through here. And you can see you have two totally different sets of ripples. You have ripples going this way, which means flow is either this way or that way. And then you have ripple marks going this way, which means flow is going that way or that way. So you have ripple marks going this way and that way along two different bedding planes. Now the rocks here are steeply dipping, and I forget if they're actually dipping behind me or if they're overturned here, but these ripple marks, like I said, are very symmetrical. Some bedding planes don't have any, but these ones up here, see how big they are? They're several inches across. We can kind of get them in cross section too, and they're pretty symmetrical. This indicates quiet water origin, shallow marine essentially. So one more quick thing about this outcrop. That's where we just were, and that way we are facing due east. But you come to the other side here and the rock's a lot darker. This may be Gauganda. I've studied a little bit the ripples we just saw, but I haven't studied this outcrop that much. It could just be lower Lorraine, but if you, as you can see here, the beds are dipping, well, essentially that way, and here they're a lot steeper. It's quite possible right through here is a fault. This is the town of Bruce Mines. I'm actually going to turn off Trans-Canada 17 from here and go north on 638, but it's a cool little town, so I thought I'd show it to you. There's outcrops here too, but we're not going to stop at them. Thessalon River. There's actually a geologic formation named for it. Okay, we are at stop 4 now. That's due west. I'm on 638. Otter Tail Lake is actually behind us over there. We are presently at GPS, let's get this in frame here, 46.36888 north minus 83.72724, which would be west. But before we do that, I actually forgot, I brought my book with me. This one was written in 2015, and it's essentially the tour we're doing right now. But I wanted to let you look at the stratigraphic column for the area. Now at the top here, you see we've already visited the Jacobsville Formation. Jacobsville, this was written in 2015 before I redefined it in 2016 last year. So it's still labeled as formation. It's actually a group now. You see the Bar River on top, the Gordon Lake, the Lorraine, and you can see that red, we're going to stop where that red conglomerate is. And you see the Gauganda. So I'm just showing you a basic stratigraphic column. Almost everything is here, but I'm just going to show you the whole thing. This is from the book, and then I'm going to show you this outcrop really quick, but I'm not going to get into too much detail on the outcrop here because we're going to see this again later. So this way is basically due west. This is Lorraine Formation, and I'm actually going to get my butt out here. Now, just basically what I want to show you here is it's the white quartzite. It's been metamorphosed. You can see we have trends this way. I believe that is bedding, like right there. But you see this here, this red. This is actually a vein of hematite, all right, that formed later after the Lorraine was deposited. And we have another smaller one right here, and it weathers out really red compared to the white. Yeah, this is bedding. This is the bedding plane. So your bedding is going this way, and the it's like this way, and your hematite is more north, dipping more north. But it's really weathers out like this. There's another really good outcrop of this which we may or may not visit. In case we don't, maybe I should do this one more thoroughly. But you look at the quartzite here, and this is Upper Lorraine Formation. See, it's very, here it's fine-grained quartzite, very fine sandstone in origin. But I think that's it for this one, so let's continue. You can see the white Lorraine at the top here of this hill. Basically, the Lorraine quartzite and the Bar River are very white in color. They stand out in sharp contrast to most of the other geologic units around here. About 9:51. We're about 46 miles into the loop here, and this way is essentially north. And here's the Lorraine again, but there's something cool here that I want to show you. We are at GPS 46.39173 minus 83.71979. And this outcrop here, like this whole area, this whole loop I'm showing you, Transcanada 17638, is heavily faulted, and mostly east-west. So you'll get a lot of repetition of stratigraphy in this area. Because remember, I showed you the Gauganda before, or the basal Lorraine before, and then the upper Lorraine. But we've been going north, and now we're back in the middle Lorraine. So what's cool about this is called pudding stone, informally, but it's the middle of the Lorraine. And when I showed you that book and I showed you the red dots, this is what they are. The quartzite here, it's still quartzite, fine to medium grain, it's a little coarser grained here. But you see these red jasper clasts everywhere. Bedding is about right there. And these jasper conglomerates, there's some white quartz in here as well, is very common in the middle Lorraine, and it's a very pretty rock. And I mean, I would love to stake this part actually, and I may do it, but here you can see the red and white quartz clasts in here. Some are decently rounded, so, but the jasper tends to be more angular. You hear that? It's a moose. So this was deposited. The Lorraine's mostly shallow marine, but it starts out shallow marine, and as you go up through the section, it becomes fluvial or stream deposits. And these, the conglomerate here, was probably deposited along bends of rivers in the point bar area. Like if a river bends this way, looking down, this is looking down, river bends this way, you get those sandbars, those point bars, and that's where this was likely deposited. And these streams were probably moving at a decent pace to deposit, to move pebbles that size. Yeah, but that's it. Let's continue north. Okay, this is stop 6. Say hi to the cows. Rock Lake is that way. We're not going to go over there. This road is basically northwest. This stretch right here. We are at GPS. I don't know if you can read that, so I'll read it to you. 46.43646 minus 83.72698. And I want to show you, remember how I said before that we have repetition because of faulting here? Back that way to the south, we had basal Lorraine, then upper Lorraine, then we were in the middle Lorraine. Now we're in the Gauganda, and the Gauganda is stratigraphically 1 unit below, geologic formation below the Lorraine. And here again we have ripple marks but I'm going to talk about them a little differently here. These ripple marks are more asymmetrical. They're thicker on the south end of the outcrop than they are on the north end. But unlike when we visited Lorraine where they change direction, different bedding planes do not have different orientations. The ripple marks are pretty consistent, showing flow is towards the southeast, although bedding is this way. This is shallow marine. The Gauganda is actually very complex. Glacial tillites, shallow marine, slates like this. But here you see, I'm just going to show you the ripples. But how do we know which way sedimentary rocks are metasedimentary in this case? How do we know their orientations? And how do we know which way's up and down? And how do we interpret all these faults and to see if they exist or not? Well, we look for sedimentary features. Ripple marks are great for that. We know ripple marks form in either streams or shallow marine environments. So the law of superposition says, they're deposited nearly flat, so each successive layer is younger. Now, that tells us that the ripple marks, since we see ripple marks, we know this is a bedding plane. All right, so we don't need to try to figure out any more complex than that. If we want to measure strike and dip, we can do it right here. There's other key features at this outcrop too that show you which way is top of bedding. Now, these beds could be overturned, and these may be casts of ripple marks as opposed to the actual ripple marks themselves, but they are not here. This is actually the actual ripple marks. And there's another indicator right here. Here you see laminations in the bedding, which coincide with the orientation of the ripple marks. So we know right here where I have my foot on is a top of a sedimentary bedding plane. Granted, the water was flowing this way, but this whole area has been highly faulted and has been metamorphosed. So the beds, even though water flows that way, the beds have been tilted facing me. But anyway, I think that's it for this, and let's continue on. Okay, we are at stop 7. Our GPS, I don't know if you can read that, is 46.44115 minus 83.72775, and 638 is still generally northwest. That's northwest there. But what I want to show you, see, we have Gauganda here. This is one of my favorite places to go. Right here. I'm going to take you down there because I want to show you something. This is actually a lot further trek than it looks. The Gauganda has basically two members to it. It has the lower Coleman member, which is where all the tillites are, and the upper First Brook member, which is mostly marine slates. And here we're north further than we were at the last stop, but here we are lower in section. And as you can see, this is mostly tillite. They quarried all the sand and gravel out of here a long time ago. But what we can see from here, I'm not going to get too close, I don't think. I don't feel like trekking down there right now. Plus you can see more here. Is the Gauganda is this typical greenish gray to nearly black. But what you can see here is this is the tillite. And the tillite has in it, you can see these massive, up here is one, these inclusions, and some are smaller. You can see some red small inclusions if you look at that. You can see it. There's a bunch over there, like right about there's one. There's a ton of them on this side here. I've been up here many times. But these are class. Actually, I am going to get down there and show you a little closer. Okay, that's where I'm parked. I've come down. Now we have the sand and gravel is glacial in origin, and this boulder here is glacial. It's not part of the original Gauganda. And it is igneous in origin. But I just like this one because you can see the cross-cutting relationships within it. Just real quick here, this would be your host rock. These dikes, which are more granitic, were intruded first and deformed a little bit, and then these red syenite dikes came in after. And this may be a healed fault, because we see offset of this dike here, and this little guy here is offset, and they're offset the same direction, relative this way and that way. So I just like that boulder because it's cool because of that. Now let's get back to the Gauganda. You can start to see these red clefts. This is all Gauganda. See if I can find one easily accessible. You can see them here. Now this is not jasper like within the Lorraine. These are actually granitic. You can see white quartz, alkali feldspars. You can see some other feldspars in it, and you can see the rounded edge in a matrix, a fine-grained matrix that has no definite orientation of bedding. Now, if this is a tillite, it's the Coleman member. It closely resembles modern glacial deposits that we see, except this was probably nearer a shoreline than what we presently have throughout the Midwest. You can see this is definitely granite. Almost all the clasts in here are granites. So that's a close-up of it. It's really hard to figure out where bedding here is. I have been unable to determine, and since it's glacial in origin, these red granite clasts are oriented randomly, so it's not like I can use their orientation to determine bedding. I thought there was one around, I mean, there's some quartz, but that's probably just broken from the granites. There was one, I think I did find a clast once of what looked like banded iron, but thought it was here. Maybe it isn't. But anyway, so here you are looking at some of the oldest glacial deposits in the world, about 2.4 billion years old. And it wouldn't be for another 2.4 billion years before glaciers returned. So this is really right here, some of the oldest glacial stuff you'll ever set your eyes on. It's part of the Huronian Supergroup. Basal Gauganda, Coleman member. I'm heading north still. This is still Gauganda. Still has some granite clasts in it, but you'll also randomly see red beds in here. Now, something else that's interesting about those red beds is it's the first time in the geologic record where these things appear. It was called the Great Oxidation, I can never say that word, event, GOE. And it's mostly, the red beds here are mostly shales or karstic sandstones. But as we head north, we're heading up section. Now we're in the First Brook member. We're out of the Coleman. The sandstones mark kind of the top of the Coleman, but you start to see these red colors, and this does have a little banded iron formation in it, in the Gauganda, near the top as well. And if I can remember where that outcrop is, I will stop at and show it to you. But this is the very first formation where red beds appear, which tells us we started getting free oxygen in the atmosphere for the very first time. And let's see here. Let's see, we go over here. Maybe we can get some here. See? Start to see some reds. You don't see that until the Gauganda. There might be some up here. So, on to the next stop. There's some good red beds in the Gauganda. Good red coloring, and it persists up into the Lorraine as well. And now we're going to get to the part of 638. I've been basically going north. It's going to start turning west up here, and so we'll be journeying west once I round the curve up here. There's the sign. Some more Gauganda there. Here's the turn up here. So once I round this, I'm not going to actually show you while I do it, but then we'll be heading west instead of north and heading back to Trans-Canada 17. Crossing the Thessalon River again. This is stop 8. I'm going to include it. I wasn't going to, but I just want to show you something really quick. It's Gauganda, First Brook member. See if I can find them here. Let's see. I am looking for ripple marks again, but special ripple marks. Here they are. That's them. I'll get back to them in a second. But first, we are at, well, it's about 10:45 Central Standard Time. And we are at 46.46882 minus 83.78806. And we are facing, this is northwestish, but you see these ripple marks here? You see how they curve and bend? How they're not linear like all the other ones we've seen? And that's interesting because these ripple marks here, they're about the same size as the ones we've seen before. But the interesting thing about them is that shape, that undulating shape. If you've ever been to a beach in Chicago or the Upper Peninsula in the dead of winter on a beach that's very fine sand, and this is mostly siltstone and slate, you'll notice the winds, the cold winds, form these types of ripples, and that's very common where it's windy and cold. So that tells us that we still had a cold type environment when this was deposited, so it was still pretty chilly out. This is, like I said, I believe the First Brook, so it's post-glacial. But this yellow part here is what people have traditionally called chert, but it is also very fine silt. It's kind of like the indurated version of what we call in modern glacial deposits rock flour, wind-blown loess. So you can see here that we still had cold conditions, at least during the beginning of the deposition of the First Brook member. Okay, we're about 60 miles into our trip. It's actually in the 40s now. The GPS of this outcrop, once I get to it, I did find the banded iron. I was surprised. And this should be the last outcrop of Gauganda that I show you, and this should be stop 9. As you can see, it's all fine-grained here. We are at GPS. I don't know if you can see it, so I'll read it. 46.46686 minus 83.79747. And this, we can get bedding on. Determine bedding. I'm going to have to get down here to show you. There is no real... I'm probably going to slide in the snow. All right. So... here we see the dark slates, and we start to see Here's some of those red colored beds I was telling you about. This part's a little deformed. Something is going on here near this outcrop. We have some sort of either this is an in-situ original debris flow or there's a fault nearby. If there is, it's covered and down in the creek. But you see right here, we do know here that this is a bedding plane. And how do we know that's a bedding plane? Well, we see vague ripples here, and we can also see distinct laminations, and we can see tiny bits of borderline banded iron. It's hematite and it's weathered out here. Weathered out pretty good. See if I can do this without killing myself. Get a better look at it. We do have darker hematite here that's not as weathered. So this thick area here, maybe about just shy of 2 feet in thickness. We have some banded iron with our slates, and like I said, this would be the bedding plane here on this side. See if there's anything else you see here. You can start to see redding. This is not banded iron. This is just red in it. So there's the outcrop. Looking at it, there's that almost nearly 2 foot thick unit with banded iron in it, with ripple marks on the top. There's faint ripple marks on this plane too. So I just wanted to show you that, and that should be the last of the Gauganda. Village of Leeburn. A lot of cliff faces here. This valley, there's cliff faces on both sides. This valley's glacial origin. It was an outwash channel, modern glacial, not Precambrian glacial. But I just wanted to show you the massive hills on either side. And as I pass through Leeburn. Out of the valley and up on the ridge again. Let's see, what else can I show you? Modern glacial boulder on ancient deposits. Actually, I am looking for something. Hopefully I can find it, because it's not in my roadside book. But I think I remember where it is. I found it. It's actually Camp Wakanda. McCarroll Lake is back here. It wasn't a Bible school, it was that. So, and I know this is it. Not a very impressive outcrop. But we are at, this is stop 10, I believe. We're at 46.45511 minus 83.91024. Now, what I want to show you here, we have some glacial here on top, a lot of boulders and erratics, modern glacial, of course. That's not what I want to show you, but as you can see, it's very coarse sand and gravel. Typical. I want to show you this. This is not a large erratic. This is actually an outcrop face that was partially buried by glacial sediments. And when you look at this, what you see here is you see something. This is not metasedimentary. This is igneous that has slightly been metamorphosed. Now, I don't know the exact size of this intrusion, but there are boulders of it right here. So my guess is it does propagate somewhat decently that way. We're probably near the edge here. And I think this is due north. We're close to it. Let me check on that. Actually, facing northeast-ish, or east-northeast-ish, actually. Yeah. So this is looking north-northeast. And what I want to talk about here is history. This is what's part of the Nipissing, what they call diabase, or just Nipissing intrusions. And these are about 2.2 billion years old. I believe they're 2.19 I don't know why I remember that, but I have trouble remembering everything else. But the interesting thing about these is the Huronian Supergroup was formed at a passive margin environment, kind of like the east coast of America, or the Gulf of Mexico, or near the Gulf of Mexico today. Like in Georgia, we see sandstones and shales. I mean, granted, they're all metamorphosed, but it shows a typical passive margin development spattered with glacial stuff. So we know that a successful rift happened. Now, this was deposited long after the passive margin sediments of the Huronians ceased. About 50 million years, if memory serves, because we have good dates of this stuff now. But it's just kind of odd to see igneous intrusions like this within a passive margin sediments with no definite orogenic event. Like, we don't have anything plowing in to the continent for about till the Precambrian orogeny, about another 500 million years later. So these intrusions are kind of odd. Now, I've explained this in other topics before as to why these may be here. Passive margins, as a basin starts to close, you can start to get subduction where the passive margin ends. So it used to be just a sediment platform, and then the ocean plate will start breaking under and subducting, and you can get intrusions like this, but there's no evidence of any volcanoes or anything. So it might have just been, plate tectonics was a little different then. So it might have just been a situation like that, and then as the plate subducted, volcanism stopped before any real volcanoes or anything could have formed. But what you see here is this is mostly gabbro right here. Nipissing intrusions are gabbro and diorites, and I have seen a diorite one before, but this one's mostly a gabbro, which is essentially very coarse-grained basalt. And these dikes tend to follow the east to west faults I mentioned earlier in the area. So we know the Huronian was already being deformed as these intruded, and you'll see things like green epidote here with some reddish semi-granitic intrusions within it. Yeah, this is mostly a gabbro, and you can see some green cercrite alteration. But that's really all I wanted to show you at this outcrop. Not a very impressive outcrop, but a significant one nonetheless. So let's get to the next stop. Coming up on stop 11 here. Outcrops on both sides of the roads. No more Galganda. We are back in Lorraine. We're at GPS 46.46759 minus 83.95171. We're at about the middle of the outcrop here. The road here, essentially northwest. There's a lot of cool stuff going on here. I might spend a few minutes here. This one is in the book. It's Lorraine. And it's got to be near the top of the Lorraine. And matter of fact, it might be the transition zone to the above-lying Gordon Lake, which is covered in the valley there. We start to see some very Gordon Lake-like deposits here. As you can see here, the Lorraine, still quartz arenite, metamorphic. It's very fine to fine grained. There's not a lot of silt in some of the beds. Some of the beds are real silty, like this one. And then here we have something that's all slate or metasiltstone right here. This bed here is only about maybe a foot thick from top to bottom. And we see some redding. So we have oxygen in the atmosphere. And you see the Lorraine has a lot of pink in it. So at this time, we were still getting oxygen thrown in our atmosphere. And this bed right here, this siltstone bed, as you follow the road stays pretty level, walking northwest right now. It starts to get some beautiful colors in it. And right about here, it kind of dips down, changes dip direction. Here it's nearly flat, kind of dipping towards me a little. And then it dips a lot more. Dips a lot more and goes under the road. It's possible there's a fault in here somewhere, but we know that we are looking at the top of the bedding planes here because we see some sedimentary structures We see some asymmetrical interference ripples through here. That's the top of that siltstone slate bed. And my interpretation is that this is a lacustrine deposit within the fluvial sands of a Lorraine, because we get back up in the typical Lorraine. And actually, as you go up from the bottom of the Lorraine here to up there, silt becomes more predominant, and this very fine defined sandstones kind of fade out. Now, there's something else I'm going to show you here. This could possibly just be a low energy bend in the river, a floodplain deposit as well. Don't really know, it's the only exposure of it, but it's not on the opposite side. So either we're on the edge of the lake, or this is just a floodplain deposit. Now, here you see these green. This is circrite. You start to see it in the Galganda. It's cool because it gives everything this kind of tannish green color, if you will. Oh, I said a bad word. I said tan. Yeah, it's just mineralization. And that tells us that, you see it throughout too, that this was quiet water. We don't see any fossils in here, obviously, because we're before everything. There were stromatolites at this time, but nothing significant, and which makes me also think that this may be a floodplain that didn't last very long. And we get up here, but what we do see up here is we see this dark, almost black sand stone right on top of it. This is the contact. It's still part of it. So we had to change an energy river, but the blackness here could be organic. It doesn't look like hematite or anything like that. And as we come this way, we're heading southeastish now, this circrite starts to dominate. We see a lot more, and then it just pinches out right here. So we have likely just changing our floodplain environment. And as you can see here, we see more circritic beds. So, which is mostly siltstone with in between the sandstone, which also could have been just floodplain type things. But as I walk here southeast, we start to see some interesting features. These, we also see bedding here weathering out in the Lorraine. These are laminations. We have some very coarse sands here. All right, just like little lenses. This thing's like that big. There's another one right above it, and then there's another one right here. So we have thick laminations with massive borderline conglomeratic things, which is probably just a lot of little fluvial stream fingers, because this is this part seems to be a terrestrial deposit, not a marine. And this is what I wanted to show you, because ILSG actually has pointed this out before. This is a hematite vein, like we saw earlier, way on the shortly after we got on 638. And you look and you see the hematite. This vein is probably hydrothermal in origin. That's our guess. Brought a lot of iron up with heated water. And it's very weathered here, maybe a foot or two thick, because it's a dike, so it goes like that. Now iron staining around it, some dark iron staining over there. But I'm going to take you to the other side of the road here and see if I can find hematite. There's really hematitic, like crystals of hematite in some of this. You can see at the top here, you see some thin bedding, thick laminations. There's not many cross-bed features. You get some right here. Most of the stuff is very flat-lying. As we transition into the Gordon Lake, this is the opposite side of the road. That's northwest. Let's see if I can find that hematite. All right, hopefully the phone won't die here if I plug it in. I'm not finding the hematite, but what we're seeing here is we're seeing very fine-grained quartz arenite siltstone. So we're in the very transition zone of the Gordon Lake. And I was going to show you, that's the side I was originally on. I was going to show you that, but something stinks over there. There's probably some dead over there. But you can see the color variation. That's secondary. I just wanted to show you the reds there. That's looking southeast. Well, sorry I didn't get to show you hematite, but let's continue. Ponies for you, Sarah. Wearing orange. Okay, this is stop 11. 46.48347 minus 84.01142. This may be the last stop. Not 100% sure, but this, I think this is where the hematite actually is. I'm traveling, that's northwest, and it makes west the road. Not a very impressive outcrop, but if I can find, I think it's right here actually. This is probably the Lorraine Formation. Yeah, here it is. It's very quartz rich. I mean, this is more of a siltstone than anything, but it's a quartz siltstone, and you can see the red beds here. I believe, if memory serves me correctly, bedding is this way. Could be wrong on that, but if it is, then that would be that strike would be west northwest. But here you can see good developed hematite crystals in the rock, and there's some more over here. The green stuff is moss, but you can see it sparkles and everything. There's some good right down there. So I just wanted to show you that. And right here we have, as you can see, it's very fine grain. It is sandy. I mean, it's a quartzite, it's all metamorphosed, but I just wanted to show you the hematite grains there. That's southeast. So that's it, and that may be the last stop. And if that's the case, the total journey I took you on was about 75 miles. I'm not sure what time it is. I can check real quick. Get that for you. It is 11:47 Central Standard Time. And that may be it. Maybe not. I'm going to continue back now. I just want to show you this real quick. I'm back on Trans-Canada 17. I actually passed this outcrop before. I'm heading back. We're at 46.5. Of course it goes dark. 46.50321 minus 84.04132. And I just wanted to show you this real quick. This is a great outcrop of the Lorraine Formation. I want to say here, it's probably Upper Lorraine. It's a very extensive outcrop. I wasn't going to put this one in, but I just thought to get a good look at it. This one shows a lot of interesting sedimentary features in it. It is, there are some siltstones in it. You can kind of see them like right here, right there. There's also glacial striations on top of it, but there's also a lot of faults going this way and that way here, and I'm not going to get up in there and turn around or anything for you, but I'm facing kind of northwestish here, but I just thought I'd just show you that one real quick. Top there is where those glacial striations were I was telling you about. This is an actual road cut, same outcrop, this way long.